Hello everyone, this is another problem on the power. The power is the energy by time. So it's like, let's say that you are considering the time concept here as well. So let me give you one example. Say that you have a pump 1 and then you have pump 2. And then pump 1 is, let's say, the 20 kilowatts and then pump 2 is 15 kilowatts. And then you are trying to empty pool. So the pump 2 is less than the power is less than pump 1, and this one will empty faster in less amount of time. Okay, that's what we mean by the power is a time concept is considered. And then for the power, we can write it as, then the power is the energy by time, and then I know that energy is F into ds, and then time is, I can take the dt, and that will be F into ds by dt. That is F into the velocity. Okay? The force into the velocity. This one shows just, or you can just take with the energy by time, depending on the problem. Yeah, the question says that the sports car has a mass of 2.3 mg. 2.3 mg makes 2.3, 10 to the power of 6, 10 to the power of negative 3. That will be 2300 kilograms. And then has an acceleration of 6 meters per second squared. It starts from rest. There is a drag resistance acting on the car, and that is 10 into V. Now, determine the power supplied to the engine. That when the time is 5 seconds. The efficiency is 68%. Okay, so I will show how do we use efficiency here. But then, we are looking for power, yes, this is what the question says. And I know that the power is the force into the velocity. And then the question is that what is the velocity? Then we need to find the velocity. And then the force is given. So that's very easy. I can just replace it. But we need to find velocity. Okay. Now let's find it. The acceleration is given. That's change of velocity with respect to time. Or in scalar form, you can just write that. Okay. And then integrate it. And then a into t. Because let's say 0 to t. And it starts from the rest. And the question says that at 5 seconds, okay, then it will be that the velocity is the acceleration times the 5, and that will be 6 times 5, and then 30 meters per second. And then the power will be just a force times the velocity. And then so then the time is to find the force. Okay. And then we have the drag force that is given as 10V. But the question says that we have to find the the force by the car, because drag is one of the forces. The car has some force, it overcomes the drag and it gives the car the acceleration. Okay, then so let's say that car supplies some force. Let's say applies some force. That overcomes the drag and also results in acceleration. And then the question is that we need to find that force, and that will be by the Newton's second law. And it says that the forces acting in x direction will be equal to m into a into x. And then force by car minus the drag force, which is in, so if I choose my x direction this way, and then this direction will be y, and there is drag force in that way, I have the velocity in that way, the force of the car that way. So that will be equal to the acceleration in that way. Okay. And then let's do that. Then F of the car will be equal to the drag force, which is 10 into V, and then plus the mass of the car, which is 2300, times the acceleration of the car, which is 6. Okay, that's the force of the car. And then the power will be equal to F of the car into the velocity V. But they are in the same direction. Okay, therefore you can just write F of the car into the V. And F of the car is 10V plus 300 times 6, and then times the V. Okay, and then the V value we have just found it is a 30 meters per second. So just replace it as 30 meters per second, and then 30 meters per second. Okay, if you do that, okay, times 30, and then that makes 423 kilowatts. And then it says that it has an efficiency of 68%. So that eta is 68%. It means that is output power is 68% of supplied power. Okay, and then in that case the supplied power will be the 423 by 0.68. Okay, and then if you do that by 0.68, and that will be 622 kilowatts. Okay, that is the result for this problem.